Think about organizing songs on a playlist on your phone. You start with a fixed number of slots, similar to a CD with limited tracks. This is similar to how arrays work in Java. They have a fixed size. Once filled, you're stuck unless you create a new, larger array and copy everything over. But what if your playlist could automatically grow as you add songs without worrying about running out of space? Even better, what if you could easily remove or reorder songs without leaving gaps or manually shuffling? In this video, you'll learn how Java collections make it possible to manage data dynamically. Collections allow you to grow, shrink, and rearrange your data structures effortlessly. There are 3 primary types of collections: list, map, and set. The basic difference between a collection and an array is that a collection does not allow the storing of a primitive type, but only an object. Primitive types must be stored in appropriate wrapper class types, like integer for an int. In fact, primitive types are automatically wrapped in wrapper classes when we add them to a collection. First, let's explore lists. A list is a sequence of objects that can grow and shrink automatically, making it flexible for various programming needs. Within the world of lists, you have several options to choose from. First up, ArrayLists. They're like arrays, but with a twist. ArrayLists come with built-in methods that make managing your data easier. Then there are stacks. Stacks work on the last in, first out principle, or LIFO. You'll use methods like push, pop, and peek to interact with the stack. And finally, there are linked lists. Picture a chain with each item linked to the next. This structure allows for efficient insertion and removal of elements. Lists are ideal for managing ordered collections of elements. The second primary type of collection is the map. Maps are collections of key-value pairs, where each key is used to find its corresponding value or object. There are hash maps that convert keys into unordered hash values for fast lookups. Then, linked hash maps are like hash maps, but the objects are ordered by insertion. And finally, tree maps are naturally ordered. Maps are essential for efficiently organizing and retrieving data based on unique keys. They are invaluable for tasks that require quick lookups and maintaining precise associations between elements. The third type of collection is one with no duplicates and is called sets. For example, a hash set has unique key-value pairs with no duplicate elements. Like linked hash maps, a linked hash set contains unique insertion-ordered elements, which means that the order of the elements stays in the same order as they are inserted. And of course, tree sets are naturally ordered. So, lists are great for managing ordered sequences of elements. Maps are perfect for storing and retrieving data using key-value pairs. And sets excel at ensuring that no duplicate elements are stored. To get a better idea of the benefits of collection types, let's examine the ArrayList in more detail. Think of an ArrayList or linked list, both of which support a collection of elements. Both allow a collection of object types with added convenience methods provided by a Java class. ArrayLists and linked list both have an impressive collection of ready-to-use methods. Let's discuss a few of them, which are common to both the classes. The add method appends an object to the end of the list, with no risk of an array out-of-bounds exception. The size method tells you how many objects are in the array list or the linked list. The clear method removes all the objects in the array list or linked list. And remove deletes the first occurrence of an object from both an array list or a linked list. In this example, there's an array list with different types of objects added: a number, a string, and a date. The size method tells us the list contains 3 items. You can retrieve and cast objects, such as extracting the string hello from the list. The remove method allows us to delete specific items, and clear wipes the list entirely, leaving it empty. So far, this video has touched on what collections are good for, like storing different types of objects in a single list. But working with collections also comes with some well-known challenges. One disadvantage is that you are never sure what type of objects are inside an array list if the underlying array is of type object. That means you must cast items to their actual type when you get items from an array. This example illustrates that when you get an object from a collection, it returns an object of type object when we do not use generics. In the example, you can see that when you create the array list, you do not state what type of object will be stored in the array list, and so you have added an integer, a string, and a date object. So when you use get, it returns an object of the object class, which has to be cast to the appropriate type. This is illustrated in the code, which gets an object instance from an array list and then casts it to a string type. Casting an object to a string works when you know the type. But what if it's a different type, like an integer or a date? Casting these to a string will cause Java to throw a class cast exception. To solve this problem, Java introduced generics, which help ensure the correct type is known at runtime. Simply put, generics are a way to enforce type safety in your collections. With generics, you can specify the type of objects a collection can hold, making your code safer and easier to read. This array list can only hold objects of type string. The ArrayList type is declared with the generics designator using angle brackets and the type string within the angle brackets. This limits the data type that can be handled by the ArrayList to strings only. This means that all the methods of the ArrayList that would have worked with the object type will now only work with the string type. This is because when it is created, you limit it with the open angle brackets string close angle bracket specifier. For example, here a generic ArrayList of type string is declared, and then the standard ArrayList method is called. Notice that casting was not needed. If you run this as an application, the output would be green, the element at index 1. Overall, generics offer several advantages, especially when working with collections. They ensure that you only add the correct type of objects to a collection. This prevents runtime errors caused by type casting issues. And since the compiler knows the type of objects in the collection, there's no need for explicit casts when retrieving elements. Generics also allow you to write more reusable code. This is because a method that works with an array list using generics can work with any type, whether it's a list of integers, strings, or any other type of object. In this video, you learned how Java collections manage data dynamically and how generics ensure type safety. By specifying object types in collections, generics eliminate the need for typecasting, reduce errors, and make your code more reusable and clear. With collections and generics in your Java toolkit, you'll be better equipped to write safer, more efficient code. Imagine scheduling a jog for Monday morning in your calendar application. You wake up and start getting ready, but receive an urgent request to attend a meeting at work, so you cancel the jog. That evening, you reschedule it for later in the week. Using an array for this would be problematic. Can you think why? Predicting the number of events a user might have each day is impractical because life doesn't always go according to plan. You need a dynamic solution that can adjust for changes, like those in your calendar. Remember those Java collections you learned already? An array list is exactly what you can use here. Array lists don't require you to set a size up front. You can add events as your day fills up and remove them as your plans change. This ability to grow or shrink dynamically makes array lists perfect for a calendar application or any situation where your data varies consistently. In this video, you will learn about array lists and how to declare and initialize them. An array list is a resizable array implementation within the Java Collections framework, part of the java.util package. It allows you to store elements sequentially, but provides the flexibility to adjust their size as you add or remove elements dynamically. This feature makes array lists useful in scenarios where the number of data elements is unpredictable or subject to frequent change. Array lists also offer built-in methods for adding, removing, and searching for elements, which is an easier and more user-friendly option than traditional arrays. So how do you declare an array list? First, you need to import the ArrayList class from the java.util package. Then you declare an array list specifying the type of elements it will hold. An array list can have elements of a generic type. This type is indicated within angle brackets. For instance, the ArrayList string is an array list that holds strings, while an ArrayList integer contains integers. Array lists can only hold objects, not primitive data types. For these cases, you cannot use primitive types like int, car, and others. Instead, you must use wrapper classes, such as integer, character, and boolean. Now let's explore how to initialize an array list. Depending on your requirements, there are several ways to initialize an array list. It's straightforward. Use the new keyword to create a different instance of an array list. Let's explore some of these techniques. Default initialization is one of the most common and straightforward options. Create a new empty array list with the default initial capacity to do this. You can also specify an initial capacity if you estimate how many elements you need. This can improve performance by resizing frequency as elements are added. However, this does not limit the array list's ability to grow or shrink as needed. You can even create a new array list directly from an existing collection of elements. This is particularly useful when you need to create a copy of a list, perhaps to manipulate it without affecting the original collection. Let's explore how to add elements now that you know how to declare and initialize an array list. Adding elements to an array list is a simple process because of the availability of overloaded methods. Let's use two methods to add elements. Using the addObject method, an element can be added to the end of the list without specifying an index. If you want to insert an element at a specific index, simply pass the object along with the index. It's important to note that array lists come with various built-in methods that make it easy to manage everyday tasks. Functions like size, isEmpty, get, set, and contains simplify common operations requiring manual implementation with traditional arrays, making your code more efficient and less error-prone. You'll explore these methods in detail later in this course. Inserting or removing elements from the middle of an array list can be slow because elements must be shifted to maintain order. For instance, imagine your day is scheduled with 5 events in an array list: morning meeting, email correspondence, study session, project work, and evening jog. Each event is stored in the order you plan to complete them. Now, imagine adding lunch with a client after email correspondence at index 2. The array list must shift study session, project work, and evening jog one position to the right to accommodate the new event. Your updated list will now show morning meeting, email correspondence, lunch with a client, study session, project work, and evening jog. In summary, array lists offer a dynamic and flexible alternative to arrays, making them effective solutions for applications where the number of data elements can change over time. Their dynamic resizing and ease of adding or removing elements offers significant advantages in many real-world programming scenarios, such as calendar applications that must account for frequent updates. How will you leverage the flexibility of array lists in your next project? The choice is yours and the potential is limitless. Imagine you are organizing your weekly schedule with a list of tasks and appointments. Some tasks might be added last minute, others might get cancelled, and you often need to check what's next on your list. Managing all these changes efficiently is precisely what an array list can help you with in programming. In this video, you will learn how to perform common operations on array lists in Java. You will understand how to add new elements, remove unnecessary ones, access specific entries, as well as how to utilize resizing methods. Let's say you're developing a calendar app where users frequently update their schedules. Fixed size arrays create bottlenecks in dynamic environments like this. Array lists, however, are dynamic arrays. They can expand or contract as needed, which makes them ideal for applications where changes are unpredictable. Imagine you need to update your daily appointments, maybe because you just realized you have an appointment that afternoon. How could you accomplish this using an array list? At its simplest, the add method can be used to add elements to the end of an array list, like a list of appointments in a calendar app. Notice that adding doctor's appointment does not require you to specify a position, unless you want it at a specific index. It simply adds to the end of the list by default or anywhere you select. The add method is also overloaded to accept an index and an element. This version inserts the element at the specified position in the list, shifting the element currently at that position and any subsequent elements to the right. This flexibility makes ArrayList practical for scenarios like these, where your schedule can change immediately. Now let's say the unexpected happens and the appointment gets cancelled. How would you consider removing this from the calendar and updating this change quickly and efficiently? ArrayList uses the remove method to delete elements from the list. You just need to specify the element directly or its index. If you want to remove the evening jog from the list, for example, just pass the object. If the element is found and removed, the method returns true. If the element is not found, it returns false. Additionally, the remove index method takes an integer index and removes the element at that index. This returns the element that was removed from the list. If you want to remove the fourth element from the list, pass index 3 and that's it. Done. When managing a list of appointments, it's often necessary to check what's next quickly. This is where the get method of ArrayList becomes extremely useful. Let's explore how you can use this method to access the day's first event. In this example, morning meeting is the first event of the day. The get call retrieves the first element of the ArrayList, making it instantly visible and accessible. You can access any element you need using the get method by knowing its index position in the list. Whether it's the first event, the last, or anything in between, all elements are readily accessible and direct. Knowing how many items are in your ArrayList can also be crucial, especially when managing a busy list of tasks or appointments. Remember here that ArrayLists utilize the size method, unlike arrays that use a length attribute. An ArrayList size method returns the number of elements in the list. This method is always up to date and reflects the current state of the list, including any additions or deletions. After adding an element, you may want to check if the element has been added or not. In this scenario, you can cross-verify using the size method. To wrap up, managing dynamic information with ArrayLists in Java offers effectiveness and efficiency. Whether adding new elements, removing unnecessary ones, accessing specific entries, or utilizing resizing methods, ArrayLists streamline the process, enhancing your development experience. ArrayLists excel in flexibility, automatically adapting their size as elements are added or removed, unlike traditional arrays with fixed lengths. This means that the size method always reflects the current count of elements, ensuring accuracy and up-to-date information. Adding or removing items is similarly straightforward. Elements are seamlessly inserted or deleted with just a few lines of code. And, thankfully, the ArrayList handles all the adjustments internally, including shifting elements to fill gaps, making these tasks virtually effortless. This stands in stark contrast to traditional arrays, where manual intervention is needed to manage elements effectively. ArrayLists simplify handling data collections in Java, making your code cleaner and your programming tasks significantly more accessible. Imagine you're building a messaging app where you store the contact information of your friends, and a food delivery app where customers can easily add, remove, or rearrange items in their order right up until they check out. Both the lists are dynamic in nature. Earlier, you learned the fundamentals of ArrayLists, including their dynamic resizing capabilities and ease of use. Now let's explore how they work in real-world scenarios to truly appreciate their power. Let us consider developing two distinct apps, a messaging app and a food delivery app. Both apps handle lists that change frequently. Whether you're managing a contact list in a messaging app or a customer order list in a food delivery app, the data is dynamic and can increase or decrease. As a result, a structure that effortlessly adjusts to the increase or decrease of customers is needed. ArrayLists shine in these situations, making data management easier for developers. Let's start with the messaging app. Users regularly update their contact lists by adding new friends, removing old contacts, or rearranging entries. A data structure is needed to accommodate these changes smoothly. ArrayLists manages these updates efficiently, maintaining a flexible and adaptable contact list. Let us suppose you have a class name friend, with properties phone number and name, with the required accessor and mutator methods, and an overloaded constructor, and a toString method. As users make new friends, they must add them to their contact list. Using an ArrayList, create a list called contact list to keep track of some contacts. You will use the generic system of declaring ArrayLists. You learned about these in the reading declaring ArrayLists. If you are not sure what that is, please go back and read it first. Here, you start off by creating an ArrayList named friendList capable of containing friend objects. The list is empty at first. When you initially use the add method to add your friend Tony, the array list gets bigger to fit the first contact. Similarly, when you add Alex and Taylor, the array list grows to accommodate the new friend objects. In other words, the list grows dynamically as new contacts are added. There is no need to worry about how much space you initially allocated. The array list takes care of that for you. Now let's say you want to remove someone from the list, like Tony. Since each friend is an object of the class friend, there are two ways that you can do this. You can remove by index or you can remove by value. We can observe that the friend list adjusts automatically, shifting elements and preserving its organization without any disruptions. We can do the same thing by passing an object of the friend class. But you must note that the object passed must be the object that was initially added. For example, creating a new object and trying to delete would not work because there would be different objects and so they would not be the same. In order for the comparison to work, you would have to override the toHash and equals method of the friend class. To do this, go to the friend class and right-click on an empty area within the class and select Generate. Then select equals and hash code. In the modal dialog, select Template to be Java 7 and Higher. The Get Class Comparison expression is selected, and the Use Getters when available checkbox is selected. Click Next. Now in the next screen, ensure the checkbox next to both the properties are selected. Click Next. Ensure the same for the next screen, and click Create. This generates the methods to compare using the values of the name and phone number of the class. Now run the main class. It works. For the sake of simplicity, let us assume that we are dealing only with an array list of strings. Imagine you're looking for a contact named Tony on the list. Now the ArrayList class provides you with a method named indexOf to search for a value. The method takes a value and returns the index of the position at which the value occurs in the array list if it is found. If it is not found, it returns -1, which would signify that it is not found, since the index value cannot be -1 as it starts from 0. You use this method to get the index of the value Tony. Since it may not exist, you use an if statement to check if the value is not -1 and only then try to access it. If you do not put the if statement, then it will throw an index out of bounds exception for the index -1. Then the get method uses that position to retrieve the actual contact name and stores it in the context variable and displays it. The same can be applied to the friend object. Remember, this will work only because you had overridden the equals and hashcode methods to compare by the properties. Let's now focus on the food delivery app example. In a food delivery app, orders can be added, removed, or adjusted before finalization. ArrayLists manage these frequent updates with ease, providing the flexibility necessary for dynamic order management. Customers often modify their orders, adding or removing items until checkout. ArrayLists adjust dynamically, expanding or contracting as needed. This capability is vital in scenarios where order sizes fluctuate significantly. For example, if the customer wants to add more items after removing the salad. When you add Caesar salad to your order list, using orderlist.add and in brackets Caesar salad, what's happening behind the scenes is pretty cool. The order list automatically adjusts its size to make room for the new items. You don't have to worry about whether there's enough space, the list just expands as needed. When you use the add method with a defined index, you're telling the order list to place tiramisu right at the top of the list at position 0. If tiramisu is already somewhere else in the list and you want to move it to the top, simply remove it first using the remove method by passing the object name, like tiramisu, and then place it back at the first position. This process of reordering is super efficient with ArrayLists because they automatically shift everything around for you, keeping the list organized without you having to manually shuffle elements. It's a quick and easy way to rearrange items exactly how you want them. ArrayLists are equipped to manage both small and large orders with equal efficiency. Whether the list contains a few items or dozens, ArrayLists effectively handle the variability, ensuring optimal performance and memory management. In scenarios requiring real-time updates, such as replacing garlic bread with cheesy breadsticks, ArrayLists enable these changes to be made effortlessly, keeping the order list accurate and up to date. With this code, you first check where garlic bread is in the list using the indexOf method. If the index isn't -1, meaning garlic bread is found, you can instantly swap it out with something else, like cheesy breadsticks, using the set method by passing the index value and object cheesy breadsticks. This allows you to make real-time updates to the order, ensuring everything stays accurate and up to date without any delay. It's a quick way to keep the list current and relevant. In the fast-paced app development world, where data constantly changes and user expectations are high, choosing the right tools can make all the difference. ArrayLists stand out as a versatile and essential solution for managing dynamic data. This video explored the practical application of ArrayLists in real-world scenarios, showcasing their ability to enhance any app's functionality and user experience. Remember, using the power of ArrayLists not only simplifies development, but also ensures that your applications can adapt to whatever challenges come their way. Building a user management app for a social platform like Instagram comes with its challenges. As the platform takes off, keeping track of things like usernames, roles, and activity logs can get tricky. Adding to the complexity, the number of users sometimes changes due to significant events or normal fluctuations. So, how will you decide whether to use an array or an array list? This decision impacts not just coding, but also how the app interacts with data. This video covers how to choose between an array and an array list, and why it's more than just coding. It's about planning and adapting to evolving software needs. Let's break down the key differences between arrays and array lists, examine how array lists manage dynamic resizing, and then discuss the efficiency and predictability of arrays. First, an array is a simple data structure that stores elements in contiguous memory locations. They're great because they allow for rapid access, but have a fixed storage capacity. For example, in a calendar app, storing the days of the week in an array is ideal because the number of days never changes. An array's fixed size is perfect for this purpose. On the other hand, an array list, part of Java's collection framework, offers a flexible way to manage data. It automatically resizes to handle adding or removing items, which makes it especially useful when data can change unpredictably. ArrayList's dynamic resizing capabilities are crucial when developing applications like a social media platform. Say a social media platform starts with just 100 users, and suddenly the platform's popularity jumps to 5,000. ArrayLists expand automatically as more users join, eliminating the need for predicted capacity. As another challenge, managing user accounts involves adding or removing users frequently. ArrayLists excel here too, due to their flexibility. Adding a user is as simple as using add user, and removing one is as easy as remove user index. Unlike arrays, you don't need to shuffle elements or worry about space constraints. In a dynamic environment like social media, where user numbers fluctuate, array lists ensure efficient and hassle-free management. But if array lists are so flexible, why use arrays? Arrays are the go-to for speed and predictability, particularly in terms of memory and processing efficiency. For example, imagine you have specific user roles like admin, moderator, and viewer. With arrays, each role has its fixed place, making it easy to access and manage. Arrays are also great for tasks requiring fast, reliable performance due to their indexing system. With arrays, performance is predictable because it can access any item directly. In fact, arrays' predictability is crucial for back-end processes, such as generating real-time analytics on user activities, where efficiency and reliability are imperative. Choosing between an array list and an array depends on whether flexibility or efficiency is needed, based on application requirements. The key is focusing on what your application needs. Let's consider some hypotheticals as a guide. If you need flexibility, choose ArrayList for its dynamic resizing. For efficiency and faster access, go with array due to its fixed size. If user counts vary or data is dynamic, use ArrayList, since it can adjust in size. If there are fixed data sets that benefit from quick access times, use array because it offers constant time access to elements. When making your decision, remember this: array lists are ideal for dynamic data, while arrays are best for static data that require quick access. The goal of selecting the right data structure is to boost your app's scalability and performance. So, keep your app's needs in mind so it can grow efficiently and effectively.